I'm assuming that everyone here is passionate about the soil because that's what I'm passionate about. And not only soil, clay soil, transforming soil, but recreating soil. And it's imperative that we take care of the soil we have, number one. But what if we could actually transform soil that's currently poor quality, non-productive, into something very healthy, very productive, that acted as carbon sink and do it very rapidly. And this is why it's important, because we need the soil to support the planet's biggest industry, which is growing food for humanity. You'd have to put a huge amount of biochar into the soil to actually sequester carbon. And it takes quite a bit of energy to transform raw, like sawdust, into biochar, because biochar is basically carbon that has been baked, ideally organic carbon that has been baked at really high temperatures for a really long time with very little or no oxygen. So you can't make this in your barbecue. You've got, you've, there are ways to make it at home, but this presentation isn't about making it. It's about how to use it. And it's been found to affect nitrous oxide, carbon dioxide, and even when you feed it to cattle, it seems to even minimize the methane that they belch. But the big problem with creating soils and creating it quickly is how it is often compaction. The surface is compacted because the land has been grazed or it's been trampled on. And in order to start that whole process of soil formation, you need air to penetrate. You have to get, and the soil can actually restructure itself. It can take, like in a clay soil, you can imagine all these little platelets. And so in a clay soil, the air and the water have to go back and forth like this between all the little clay platelets in order to start getting that. It takes a long time. That's why clay doesn't drain very well, and it's hard to get roots in it. You can't get the oxygen down. But in a healthy soil, the clay and everything else has been aggregated into clumps, and you start getting pore space. And it seems as though the real value of the biochar in the work that we've been doing with the City to Farm project, which my husband's going to talk about next, is biochar's ability to act to flocculate clay platelets, which is all those little tiny platelets, which you can only see at the level of an electron microscope. It's clumping them together on a micro scale. Biochar has a number of really interesting properties. One of them is an electrical charge. It's usually a negative charge, but there's some biochars that have a positive and a negative charge. And the little clay platelets also have a charge. And so when you put biochar in with the clay, it actually changes. This is probably too technical. You know how a magnet clumps the positive and the negative sides together? Well, when you put biochar in, it acts like a little magnet to the clay platelets, and they stick to the biochar and they start clumping it together. Yeah, you can pass it around. You can feel it. Do not go, because that's the one health and safety issue with biochar. You always want to keep it damp. You never want to breathe it. Have you heard of the disease, black lung disease? Coal miners get it. You can get it from breathing biochar. So if you use it's safe on your hands, safe on your clothes. You can't get it out, but it doesn't hurt anything. But don't breathe it. Now this is a real fine biochar made out of baked, what's actually called pyrolyzed sawdust, and it comes from a sawmill in Rotorua, and it's basically a high carbon boiler ash. And we buy it in bulk from a company called Soil Pro in Mercer, who've been mining this old landfill full of high carbon boiler ash, and we've been using it on the City to Farm project. But if that's the case, if the real value of biochar is to start restructuring soil, it offers the potential to transform clay and any other soil really into topsoil much more quickly. Now, we're going to put this on hold for a minute. We're going to go back. There's a history. There is an example of transforming clay soil into topsoil really quickly. Who here has heard of something called terra preta? Some show of hands. Not too many. Oh, I get to tell the story. Such a great story. Okay, so back in the 1500s, the Portuguese explorers went up the Amazon and they wrote in their diaries about these wonderful white cities that they saw lining the Amazon River. And then 20 or 30 years later, when the next set of explorers came through, they went, where's these blasted cities? We want to get their gold. Where they're gone. All they see is jungle. And so they reckon that the first explorers made it up. And everybody else from then on thought that the first explorers made it up. But then in the 1970s, some anthropologists and archaeologists took these old diaries and they went to the places where these cities were supposed to occur, and they dug holes. And what they found was they found topsoil, 0.5 meter, 1 meter, 2 meters deep, beautiful, black, rich topsoil. Now, if you know about soils, you know this is impossible. In terms of modern science, this is impossible because clay soils, especially in the Amazon, are some of the worst in the world. They've been mined and leached for millennia, for probably hundreds, thousands of millennia. The jungle has taken all the nutrients up, put it in its biomass. The rain has leached out the remaining minerals. And if you cut down the forest, you have nothing left. It's all that goodness is in the forest. And so this terrible, terrible clay soil is this beautiful, black, rich, deep topsoil. And for a long time, the scientists said, somehow it just managed to change itself. But the archaeologists and the anthropologists start digging in this stuff, and they find pottery shards. They do DNA analysis and find that it has old plant material, human feces, bones, shells. It was man-made. And the anthropologists and archaeologists started digging holes all over the place, and they found there's an area probably about the size of France in the Amazon basin with these soils in it. Now, how in the world did these people make this stuff? Something that is really unique about terra, there's a whole bunch of things that are really unique about terra preta. It has biochar in it. So they obviously made charcoal. How they made it without big metal tanks like we do it today, there is a huge amount of fungal mass in it, particularly something called glomalin, which is also an extremely stable carbon sink. There's the pottery shards and a lot of organic matter. Now, in the jungle, again, you cannot compost. You can't make compost and dig it in the soil and have it last in a jungle environment because it breaks down so quickly. It just goes right up into the biomass and it just disappears. And that's the same problem we have here in New Zealand in many places. We dig in the compost, it disappears, we have to dig in more. And if you incorporate biochar into the soil, it stays there permanently. Okay, next slide. And so what this is about is how can we take terrible clay soil or poor quality, well, actually, even the pukekohe growers are investing in this stuff. They're buying it by the thousands of cubic meters because they find that if they work it into their pukekohe soils, they don't get soil erosion. Again, the biochar clings. But this is the soil that we started to work with. It was a white, heavy clay soil. It had a 1% organic matter content, very, very low in minerals. And this is what it is now. Okay, next. That's about 3 years, which is light speed in terms of soil formation. And these are all the different reasons to do it. We've talked about this over and over again, so I'm not going to go through it. Well, I guess maybe I should. But as these properties are also the same properties of terra preta. So all the things that we would do to improve our soil is exactly what the Amazonians wanted to do to improve their soil. And basically, it enables you to take non-productive land and make it productive. But the really big question now is how long did it take? Next. I'm trying to get to the conservation ag slides. Okay, so it's been well proven by soil scientists and agronomists around the world that if you do 3 things, you will develop and keep topsoil. If you establish a permanent soil cover, if you do diversified crop rotations, and if you only till a very small surface layer and not disturb the underlying layers, you will gradually, very gradually, build topsoil. But it's slow. Next. So how did they do it to make it faster? Next. Uh, this was obviously made for a different presentation, not for an outdoor workshop. But here you can see where they've done slash and burn agriculture, and they've just planted in an area that had just been slashed and burned, and you can see the size of the corn. And here is a place where there's terra preta, and it's been there for a long time, and they're growing corn in it. And the amazing thing about that is they're growing corn in the same place over and over again. And the terra preta is not losing its fertility. How can that be? Because we've been told that plants take minerals out and you have to replace them. But this stuff has been fertile for over 500 years. And that's another real mystery about terra preta, because what should happen in a jungle is all of those minerals would be taken up again by the biomass and again deplete the soil. Next. So what we're doing on the City to Farm project is we're doing conservation agriculture. We're maintaining a permanent soil cover. Well, we're not doing any crop rotations because we're growing bananas, and we're not disturbing the soil, but we're also adding biochar. We're avoiding chemical fertilizers. We actually inoculated the banana roots with mycorrhizal fungi. That's that one. And we are encouraging a diverse number of crops growing underneath bananas. So, and David has been doing soil testing over time, over the past 5 years, and he'll be talking about the City to Farm project. But we're thinking that this is probably what the Amazonians did, but we want to find out, how long does it take? Next. So here's a picture of biochar underneath an electron microscope. You can see it's really porous. And this is another property of biochar, which I can't get my head around. Supposedly, if you have a gram of dry biochar, it has between 30 and 80 square meters of surface area inside. Yes, I know. It's it's, and some people describe it as the condominium for microorganisms, because soil bacteria is about the size of a lot of the pores on this, and they can live inside, they can coat it inside the spaces, they can coat the outside. They love living in it. And it seems as though the real benefit of the biochar is not in terms of sequestering carbon, it's not the biochar carbon in the soil, it's the ability of the biochar to house microorganisms and to increase the microbiome of the soil. And because it's the little things are living inside, when it rains, the nutrients don't leach. Um, and yet, the plants, they must have a banking systems with the plant roots. The plants take it out, but the plants must be putting it back because it doesn't lose its fertility. We don't understand how that works. But there's a term in India called a rasayana. Ever heard the term rasayana? It's a it's a herbal remedy that people take that helps all aspects of health. And I think of biochar as being like a rasayana for the soil. It seems to help everything. Now, I'm under the impression that the Maori people made charcoal and they worked it into their soils for a lot of different reasons. Now, we talked about how biochar picks up minerals. Well, and how it houses microorganisms. If you put biochar, the stuff you made, into your garden straight, it is going to rob your soil of minerals and microorganisms. You're putting it in the compost heap. Great. And make sure that compost is wet. Good. Okay, you can put it in a worm bin. You can put it through a bokashi system. Yeah, now the worms love it because they're like chickens. They need a bit of grit to I feed all my children biochar. Um, yeah, so you, they need a bit of grit to grind up their food. And so when the biochar goes through the gut of the worm, it gets populated by all those microorganisms in the worm's gut. And it's actually one of the very best ways to both inoculate. Inoculate means to add microorganisms, and to charge, which means to add minerals to the biochar. We do it for the City to Farm project. We do it through bokashi, and basically we take 15-liter buckets with woody mulch in the bottom, biochar in the bottom, and then we layer up the food scraps with the bokashi zinc and tamp it down. So usually bokashi is a 2-bucket system. We use the 1-bucket system, and that means that biochar is going to get saturated by that liquid that's breaking down the food scraps. Yes. Um, yeah, it's made by it's also known as EM, effective microorganisms. And Zing is just a brand name. We've played with the stuff you get from Bunnings, and it didn't do anything. So now we get the good stuff from Christchurch. The technique that we're using at the City to Farm project is we're using bokashi with biochar for a number of reasons. Biochar is also very alkaline, and bokashi is very acidic. So usually you have to drain off your bokashi juice in order to and put it someplace else, or dilute it, 50-1 to use it on your garden because it's too acidic. And it's also full of phytotoxins, vinegars, acetates. That's another reason to dilute it. It has lots of minerals, lots of goodness, lots of nitrogen in it, but you have to dilute it. But we have found that if you use the biochar in it, you don't seem to have to do that. And you can dump the entire bucket into a hole in the ground, which makes it easier. Um, and also the City to Farm project, when we're composting in the swales, it turns into a giant worm farm. So basically we're feeding the bananas with vermicast and with minerals and microorganisms from the bokashi. Next. We have a master's student now. I don't know if are any of you with the Biochar Network New Zealand? If you might go onto their website, because if you want to have a biochar demonstration, if you want to see what they're doing, they have heaps of resources. It's called Biochar Network New Zealand. And um, they've come out and done demonstrations for people. Why did I bring that up? Biochar also seems to stimulate fungal growth. And you can't have fungal growth until you start getting porosity, until you start aggregating your soil. There's actually 3 stages to soil formation in clay. And the first one is on that electron microscope level of flocculating the clay platelets around the biochar, that electrical charge stuff. The next phase is bacterial, where the soil microorganisms start populating that biochar and they start drawing in organic matter and other bits of minerals, and they stick it all together. They aggregate it to make something called microaggregates. And then their third phase is when the fungi come in and they start aggregating. I'm sorry if this is too technical. If they start aggregating the 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 microaggregates into macroaggregates, and that's when you get the real porous soil, and that is when you've got prime agricultural soil. Is it terra preta? Well, we don't know. Um, the master's student is going to be working on documenting the changes that have been happening over the 6 years on the Terra Preta project, and also digging new swales and putting biochar in one and food scraps, and no biochar and food scraps in the other. And he's going to start also doing the soil food web analysis to look at the microbiome. Yeah.
Go through that 3-stage process, not the stages, the bacteria and the fungi. Do you need to dig in the biochar into the clay, or can you put it on top?
That's it should always be underneath the soil, because you might have missed out on the first bit where you shouldn't breathe this stuff. So if you put it on the surface of the soil and the soil dries out, it can blow around and you can breathe it. If you put it in the soil, then you're going to start getting that interaction with the soil particles. So
Do you want to put it in the soil directly or after it's gone through the composting?
after it's gone through the composting process, and it works well in the swale system because we have layers of mulch over it. So it's, even though it's on the surface, the mulch is on the top, and those, we have compost worms, but lots of other worms in there that seem to be pulling it down into the soil. Yeah.
So what happened when we first had our biochar, we put it in some compost and put some seeds and some plants in, and all the plants died.
Yes.
How much biochar for a garden or for clay?
Okay, so you're looking at in terms of volume, 10 to 1. So if you want to improve 300 of soil, you want to work in 3 centimeters. So 30 centimeters of soil, 3 centimeters of biochar. If you want to do a meter, you're going to put in 10 centimeters. But of course, you can't work it down that deep. So you may as well. And the past president of Biochar Network New Zealand, Warwick Isaacson, reckoned one of the coolest ways to do it over a large area would be to use an injector and a tractor, and basically get a big tank of compost tea, add biochar to it, keep it aerated, keep it bubbling, and then inject it. You know how it rips through the soil, and it actually injects the biochar and the compost tea right into the surface area. And if you did that parallel to the contours or just slightly off the contours, you would start getting that benefit. Yes.
So what size are you trying to achieve from biochar when you're talking about injecting it?
In ingesting it?
Injecting.
Injecting. Oh, you're probably looking at probably 150 to 200 deep.
Yeah. But so what are the particles of the biochar?
It's this really fine stuff. Yeah, you have to use, if you make it yourself, you'll get big chunks, and then you have to Some people put it in a bag and drive their car back and forth over it to grind it up. But you need something quite fine if you're going to do work with soils. Yeah, true, true. Yeah. Uh-huh. By volume, right. Um, yes. In fact, there's heaps of studies of the benefits of adding, because biochar acts as a permanent form of compost in the soil. It holds on to water, it holds on to minerals, it changes the soil structure, but it doesn't decompose. And that's exactly what they recommend for sandy soils, adding lots of compost. But if you use biochar, you've done it permanently.
Holding on to water.
Yeah. Yeah, exactly. And it also stops that leaching of minerals.
They're mining it.
And
Yeah.
it's really sad, isn't it? But maybe that's because they don't know how easy it is to make.
Well, and it's also like red plants that they're mining it.
Yeah, I've heard that too. That's another thing I can't get my head around. I wasn't going to bring it up because I don't know if I believe it yet.
Reports of that, so I'm not too sure. But it seems like they're onto something.
Yes. So
It's greenwash.
so what he's saying is there are people that are claiming that you dig out the biochar, you leave it for 20 years, you come back and it's grown back. And but maybe it does. I mean, maybe what terra preta actually is a climax ecosystem of soil microorganisms. When they did the DNA analysis on biochar, they found there was an incredible diversity of soil microorganisms in there and all different types of fungi. And there's some BBC documentaries out there that you can watch. And at the end of one of them, there's this guy that says, the scientist who's saying, we're going to find out the one thing that's in the biochar so we can replicate it in the lab and make more. And it's like, good luck. Okay, next. Yeah, this is just, David will talk more about that, how we're doing it, the banana farming in the swales. Well, let's talk, is that the end?
No.
Let's talk about something called cation exchange capacity. For those who have heard that term before, it's the ability of the soil to hold on to minerals. And if you imagine the soil as a sponge, generally the finer textured soils like clay and silt, they have a greater surface area. They have more places where minerals can stick. And so clay soils usually have a fairly high cation exchange capacity. And when I was a certification manager for Organic Farm New Zealand, I had to look at all of these soil reports that would come in from around our region. And the clay soils usually had a range of between 16 and 26, a high cation exchange capacity. Biochar can have a cation exchange capacity of over 200. Yes. So to me, the real potential here for biochar, using biochar, is to create carbon sinks. Carbon sinks that we can farm. Carbon sinks where we can take crap soil and make it beautiful and productive and do it permanently. Next. That might be the end. Like I say, this was actually for a different presentation. That's all your stuff, isn't it? Yeah. Okay, so we'll stop there. Well, if there's all different types of biochar, and it depends on how it's made. It depends on the type of material that's put in it, how long it's baked, the temperature, and how much oxygen. So at one end, if you have really hard, dense hardwoods at a really high temperature for a really long time, you will get an extremely stable form of carbon. You'll get that biochar that will last in the soil for thousands of years. If you use a softwood, like pine, and for a moderate length of time, you'll get something that is both has fertilizer capacity and carbon stability in the soil, but it won't last as long as that super hard miro or wattle. So, and then if you, for a short period of time with lots of oxygen, you get this stuff, wood ash. So, and there are experts in the biochar field, and I'm not one of them, who can actually say, this is the type of biochar you need for your specific application. But right now, we don't have any big biochar producers here in New Zealand. And there's somebody in Silverdale who's talking about putting up a pyrolysis plant. Waitakere Concourse, the Auckland City Council is talking about they're researching making biochar out of the green waste that comes in. You don't industrial quantities, but you don't want to biochar treated wood, you know, and you don't want to buy. The biochar industry was almost, well, maybe it has been hijacked in some places by the waste industry, who talk about taking mixed municipal waste and pyrolyzing it, which is the same way you make biochar, and making this black stuff and putting it in the ground. We can get rid of your problems for you, but you don't want to put it in the ground. So you have to be really, if you research biochar, where you're going to get it, find out where it's coming from. You can go to the garden centers and you can buy these little bags of biochar from China made out of bamboo. Bamboo makes a great biochar, but it's been soaked in chemical fertilizers to inoculate it and charge it. So, and in fact, there are farmers in Australia who use biochar, soak it in chemical fertilizers, and use it as a slow release fertilizer. So, yeah, know what you're getting into. I would go online. Does anybody here know people that make biochar?
There's some, there's some places up in Waikato, but I don't know. You know, like they're just home family people that.
Yeah.
I got some at the gate. Thanks. Oh, please. Yeah,
Mhm.
yeah, sounds right.
We've got a grant from the council. A portable one on a trailer.
Yep.
And he has workshops.
That would be a fantastic way to have a whole bunch of permaculture people come together. That would be amazing to watch. Could you share that with me? And perhaps I can share it with hopefully the network.
Mhm.
Yeah. Yeah.
The grassroots innovation, they collaborate with companies all over the way.
Uh-huh.
Rid of the waste.
Tolaga Bay, all that slash on the beach.
So they have now on route,
Yep.
then drive it straight to the forestry sites
Uh-huh.
and to the cheap.
Yes. Excellent. Yeah.
I've been researching a bit of. I think that's sometimes the issue. Biochar, like there's so much research done on it, so many different details how you do it, what temperature you use, is the carbon sink, is it not? It depends on how wet the material you put in there. End up burning water instead of organic.
Yeah, it's
Yeah.
best to use dry material. Yeah.
I love
Yeah.
Yeah.
it would be nice.
Uh-huh. I'm glad this is being recorded because I'm not writing it down. I would love to. So say that again? Ashurst. Yep. And their names? Phil Stevens. Yes. Okay. He's a member of the New Zealand Biochar Network. Great. Yeah. And there's a fellow in Orewa called Warwick Isaacson with a company called Charbro. they've got a pyrolysis unit set up in the Riverhead Forest, and they're processing slash out of the pine forest there. And I know you can get it from him online in 20-liter buckets, but if there's something closer to you in your area, you know, please look into that. That could be. His family's from the West Coast or the West Auckland. Yeah, and he's with the iwi. He has ties to the iwi.
So there are occasions.
Well, yeah, because you want to process it when it's dry, which is in the summer, which is also when. So ideally, if there was a workshop there to be a place where it could all be piled up and covered until it was, you do it in the winter. Mhm. Yeah. And there's so many different. Oh, his name is, well, the company name is Soil Conditioning Products, Soil Conditioner Products. And they're in Mercer, but you have to buy it by cubic meter bags and pay for shipping. And you need to have a forklift on the other end to take it off the truck. So, no, it's raw. Well, he has different products. You can get biochar that has been composted with chicken manure and lime, agricultural lime. And I'll tell you, you put that in anywhere and you have fantastic growth. It's really good stuff. So, Soil Conditioner Products. They're down in Mercer. But, you know, again, you need a forklift to unload it from the other end. Or a, you know, a tractor with a bucket that you can get in underneath the pallet. Yeah.
I just saw a video on some environment video here showing around, and there was a woman she just makes her own and basically in a fire each night. Is that
Yeah, that was you can make your own.
but it was just a plain
Yeah. You can use a Milo tin. You can use a Milo tin, a metal Milo tin. You can take dried coffee grounds, fill it 2/3 full, put the lid on nice and tight, poke 3 holes in the bottom of it, kind of close to each other, and put it in your fire.
Making a small amount, but it's gold or diamonds, it doesn't matter. It's a small amount. Not a very large area.
yeah, well she can read food specs in there every morning.
Yeah, but then you'd have to crunch it up if you wanted to put it in soil. I'm not an expert on making it. I just use it. So,
Have lead in the paint or
But it's no ears, right?
yeah, well, I've seen them where they have these cones, and it's similar to what Brian was talking about, where you light the fire in the bottom, and it's a solid cone, so no air comes in on the bottom. You pile up sticks, you know, get the fire going in the bottom, get that going, and then you feed the top. And basically, what happens is the wood underneath is starved of oxygen, and you just continually you're adding sticks on top and keeping the fire on the top and the oxygen out of the bottom. You do not get a really high quality biochar with that. You do get biochar. You know, you're talking about good quality biochar at over 400 degrees for at least 4 hours. And you're not going to get that necessarily in a cone situation, but you do get biochar and you can use it.
I've just been using 2 stainless steel sinks, like 1-piece stainless steel sinks, cycled from the reuse center. then I just thought, okay, that one will fit on top of the other one, enough to exclude the oxygen. So I set it all on fire and then second sink on top as a lid.
Yeah. Did you get black stuff or white stuff
I got kind of
or both?
charred. Well, I use bones as well because I think it's very important. Bone char. You put bones in as well, not just get carbon, but get phosphate, which of course we're now
Mhm.
deficient.
Well, yes and no.
The phosphates, if you don't put bones in another way,
Yeah.
phosphate another way via bones.
I'd like to talk to that phosphate issue.
Yeah.
Because phosphate, we've there's so many farms that have been putting phosphate on for years and years and years. And there's actually heaps of phosphate in the soil, but it's not available. When you add biochar, when you get that soil microbiome working, it starts releasing the phosphorus that's in the soil.
You don't need that much phosphate, it just needs to be available.
That's right. And so when you add the biochar and you get the soil microbiome going, those microorganisms start working on breaking down and making available the phosphorus that's already in the soil. Yeah.
One of the reasons.
Really? Huh.
The decades of phosphate accumulate that subsoil level. It's sitting around the grain, saturated grain, and releases it. That's one of the problems.
Well,
So, biochar that's in the soil.
let's talk about remediation. Because biochar has been used for soil remediation for contaminated sites. So places where they used to tannalize timber, places where there are toxic waste dumps. You can put biochar in it and it will sponge up a lot of those really nasty heavy metals, persistent organic, what are they called? Yeah. And interestingly, they're not available to the plants, or rather the plants then have a choice as to whether or not they want to access that or not. And they can turn areas that were once completely dead, completely poisoned, into lush, fertile pastures again. Whether or not you want your cattle to eat on them, I don't know, but biochar can be used in that way. And some people are saying they don't want to use biochar because they're afraid that it'll soak up all the toxins from the food scraps or from past soil things and it'll poison their soil. Just the opposite. It actually binds it up, makes it unavailable. You'd still want to inoculate and charge your biochar before you put it on top of the soil, and you'd want to maintain that mulch on the top all the time so that biochar didn't dry out and blow around. And that would be a really easy experiment, because one of the big questions that there's scientists now in the Amazon, and they've met tribes that supposedly still make this stuff, although I don't think the tribes actually do know what they're doing. But they're talking about how they just put the biochar right on the surface of the ground, pile up the organic matter on top, and just let it sit. And in a few years, it would become terra preta. So it'd be an interesting experiment to try and see if it works, because it would be a lot less effort, particularly if you're dealing with really large areas. Lots of Tithonia. Yeah, now see, that would not make a high quality biochar, because the mulch. Okay, great. Yeah. 2 more minutes. Any more questions? Yes. Massey University had a biochar department, but they were focusing on testing things in pots, not in the ground. There are very, very few research projects that actually look at on the ground, in situ effects of biochar. And a lot of, and it, I can understand the reasoning because they were trying to work out what type of biochar, what is the best biochar to use. Whereas we just took biochar and just land applied it to see what would happen. But Massey lost their funding. But there are still profs at Massey Palmerston North. And do you know anything about this, Lindsay? Yeah, you're in Albany and they're down in. And there, if you go into Google Scholar or use AI, go into AI, ask questions. Biochar is one of the most researched topics on the planet, but a lot of it is highly technical. And they're talking about, electrochemical reactions with blah, blah, blah. And what you want to find is land application, examples of land application of biochar. And ideally, in a climate similar to ours, because yeah, you get really different results. It's very different in the tropics than it is in temperate regions. Yes, yes. It really stimulates fungal growth and a diversity of fungi. And if you pre-inoculate your plants with, um, you can actually buy New Zealand mycorrhizal fungi spores and inoculate stuff with it. Well, that's the thing. We stopped after a while because people told us they were everywhere. But they can be killed by excessive nitrogen and phosphorus, which probably relates to what you were talking about, Kathy, because the high levels of phosphate in the soil would probably knock the fungal balance out. It would probably kill the beneficial fungi and leave the nasty phytophthora there to replicate.